Okay, this is page 3 of the review. So I started a minute ago, but the remainder theorem, if you remember, says if you take the 0 of the divisor, so I've taken x minus 5 equals 0, so add 5, x equals 5. I've taken, if I plug 5 into this polynomial, so 5 to the third minus 5 times 5 squared minus 7 times 5 plus 25. Whatever that equals should match the remainder when I divide. So 5 to the third is 125 minus 5 squared is 25 times 5, which is also 125, minus 7 times 5, which is 35, plus 25. So basically all I have is negative 35 plus 25 is negative 10. So negative 10 should be the remainder when I divide this polynomial by x minus 5. So we'll try it. I'll put the 0 of the divisor in synthetic division. That's what I put in the corner. Coefficients are 1, negative 5, negative 7, and 25. Bring the 1 down. 1 times 5 is 5. 0 times 5 is 0. Negative 7 times 5 is negative 35. And what do you know? Negative 10 is my remainder. So I have verified the remainder theorem. To determine whether something is a factor or not, really, I think synthetic division is the quickest way, but we can do a couple different ways. So one of the things we can do is take the 0 of this term. So if x plus 4 is a factor, x equals 4 plugged into the original should give me 0. So I'm going to try that. So I'm going to do 4 to the third plus 3 times 4 squared minus 10 times 4 minus 24. So 4 to the third is 16 times 4, which is 64. 4 squared is 16 times 3 is 48. Minus 40 and minus 24. Gosh, I might need to get a calculator. 64, these two together would be 8. This is not going to equal 0. So I'm going to say no, x plus 4 is not a factor. Another way I could have done it is to take the 0 of the term I'm thinking of, which is 4, and do synthetic division, and then see if I get a remainder, which the remainder would equal whatever this equals. So for that one, for this one, I'm going to do that. I'm going to divide x minus 3 divided by this. I'm going to put 3 in the corner, and my coefficients are 1, 3, negative 10, and negative 24. So bring the 1 down. 3 times 1 is 3. Adding, I get 6. 3 times 6 is 18. Negative 10 plus 18 is 8. 8 times 3 is 24. Ooh, I got 0 for a remainder, which means x minus 3 is a factor. And actually, my result also means that if I divided, I'd get x minus 3 times, I go down 1 degree, so 1x squared plus 6x plus 8. So that would be factored form of this guy. Last one is x plus 6. I'm going to do long division with this one. And I could do synthetic division, or I could plug in negative 6 in place of the x. Any one of those methods would tell me if x plus 6 is a factor. So these are kind of two different methods. You can plug in the 0 of the divisor, and if you get 0 for a result, you know you've got a factor. Or you can do long division, or you can do, this is synthetic. So I'm going to do this one with long division. X to the third plus 3x squared minus 10x minus 24. X times x squared gives me x to the third, distribute to both, plus 6x squared, and subtract. So that's 0. 3x squared minus 6x squared is negative 3x squared minus 10x minus 24. Oops, 24, there we go. And then the next step, I'm going to put negative 3 here. Negative 3 times x is negative 3x squared. Negative 3 times 6 is negative 18. What did I do? Oh, this is an x with it. So this is 3x squared, this is 18x. And again, I'm subtracting. So those first terms are gone. Negative 10 minus negative 18 is plus 18, so 8x minus 24. Up here, I'll put 8. 8 times x is 8x. 8 times 6 is 48. Subtracting, oh, I get a remainder, so this is not a factor. Negative 24 minus 48, what would that be? Negative 72, I think. So anyway, the case that I get a remainder means it's not a factor. I better double check that. I think so. Okay, here we go to the end. Sketch the factors, sketch the graph by finding the factors. So we're going to factor this. I notice the thing I really want you to focus on is look at what do all these have in common. Remember we did that GridWorks worksheet. You're supposed to really look at what could you factor out. So finding zeros, I'm putting 0 on this side. And then I'm thinking about, I got to factor this thing because x to the third, I don't know how to do quadratic, there's no quadratic formula for that. But notice x, 2, 2, 2. So I'm going to factor out a 2x because all three terms have that in common. So then I'll have x squared minus 6x minus 3. Okay, well, that's not too bad. So then I've got that equals 0. And then 2x equaling 0. Oops, you can't see that. X equals 0. So I know x equals 0 is one of the answers. And then the other answer, I'm going to have to do quadratic formula because I can't factor this. There's no product of 3 and sum of 6 that I can find. So x equals negative b. So negative 6 plus or minus the square root of b squared. So negative 6 squared goes in parentheses. That's going to be a positive 36 minus 4 times 1 times negative 3, 4ac, all over 2 times 1. So this is not a very nice one. But I got 6 plus or minus. This is 36 plus 12. So the square root of 48 all over 2. So graphing that, I would have to grab a calculator and see what this is approximately equal to, and then put those two x values on. I do know that this is 2x cubed for the leading coefficient, so it's going to start down here and end down here. I just don't know what this equals without grabbing a calculator, so I'll do that in a minute. This one, oh, that's so nice. They factored it for us already. So if it wasn't factored, I need to factor it. This one's factored, so I can find out 2x equals 0. So x equals 0. X plus 1 equals 0. So x equals negative 1. X minus 3 equals 0. So x equals 3. So 3, negative 1, and 0 are my x-intercepts. Also notice the coefficient is 2. If I multiplied this all out, my first term would be 2 times x times x times x. So 2x to the third. So again, it starts down here, ends up here. So I don't know exactly what it looks like, but that's something like what it would look like. So it's just a sketch. I'm just doing my best. So start down here, go through. I knew it was going to have 3 x-intercepts, and it does. And so 1, 2, 3 x-intercepts. So I'll have to figure out what this one equals. I'll put that on Canvas, but here's a picture of what that last page looks like. Don't copy these, you do them yourself, and then see, because you might choose different methods for each, but these are the 3 methods that I can think of.